Well, in this video I'm going to show a software that I'm making for this 8595E spectrum analyzer from HP, and probably should work in the in all the series, 90 series or 8560 series, maybe in others, or shouldn't be difficult to adapt. So this spectrum analyzer is quite nice. It's up to 6.5 gigahertz, and it lacks of tracking generator, but the tracking generator only goes if it's installed up to 2.9 gigahertz. So it's not very useful for me, even in case that I would have one. So I need to go to 6 gigahertz at least. So apart of that, it's quite nice. There is options for it. I have gate, I have a high precision reference that it has a oven control oscillator, but I have it connected to the GPS DO, and before I had that connected. This one looks better, but I cannot get it work with the computer, so to see what it does. So I cannot be sure. I will make the test. So what I'm also this spectrum analyzer, it has support for noise figure measurements. So it has compatibility with this calibrated noise source. So this one, or the HP version, that they are calibrated. So it is compatible, but it's an option that you need a memory card there. So, but also this is a mid-range spec. In theory it's heavy and it's big, but in that time it was a portable one. So it's a field one, like a Firefox of 30 years ago. So what happened is this one doesn't have the option, and apart you need the memory card. Maybe you get the option, but you don't get the memory card, and it's not easy to find. But anyway, because it's a mid-range, probably it got the personality, noise figure personality, because from the other range that was, but this one doesn't have a very nice noise floor. And now with the GPS, I improved the original specs, and with the software that I'm making, 10 dB in phase noise, 10, 12. So it's even improving. I need, or it's convenient to use LNA to raise the noise floor with when it's connected. And I use the WIP method. So this is a very low noise figure LNA. It's mini circuits one is 600 to 8000 megahertz, 8 gigahertz, and for the lower range I have a similar one that is 1 giga and is to cover the, but it has a little higher low noise. This one have a 1.4, so doesn't damage the measurements, so even improve it. So what I did with the software is make an automatic noise figure software, a software-based tracking generator with a synthesized mini circuits generator that it has a sweep function. But you can use also a SDR, for example, if you want. But obviously this is a lot better. So, and it uses Tiger, hardware Tiger mode. So this one is connected the trigger to the spectrum analyzer, and it sweeps at the same time and in the same frequency. So it's like a hardware based tracking generator, but it goes to 6 GHz, not to 2.9. The mini circuits is up to 6 GHz, 1 mega 6 GHz synthesizer generator. So, and also I have a HP manual 70 is 81 dB, but it's fixed always, and it has a mini circuits lead, and that is a DC blocker. It's no, I have other that is better, but I use it for noise figure. I use that cable with a noise source. So the software and the GPSDO, as it loads and the LNA, and the software automatically allow me measure noise figure without the optional personality. Also, I made in the software a phase noise measurement. That is the one that I have here. This is a standalone module from the other software, but so the other can call this and be together in the menu, but this is a standalone, you can use it. So this works. I make a baseline measurement. So I measure the phase noise of the spectrum analyzer that is connected to the GPSDO, and I do the measurement with the mini circuits that it has a very low phase noise, and it's a lot better than the spectrum one of the analyzer one. So we take the measurement of phase noise of the spectrum analyzer, and when we make the measurement of the diode, you remove the phase noise, and what left is the diode phase noise. So it's a 2 steps. So first you measure the spectrum analyzer and baseline the profile, and you need to do with every frequency that you want and every equipment that you want, but it stores the file, and if you measure the same data again, we'll find if you had a previous one compatible, and we'll give you the option to load and save this step. So I put it in automatic. I can do it in manual in case that you have other sweeper or other generator, like for example CRTU. So you can use different generators. You don't need to have that one, but the automatic is with a mini circuit one. But it's difficult that you have one, but you can use your own. So, and first that it does is clean the spectrum analyzer and start to measure the power of the carrier. So I need that it takes a very precise measurement of the carrier, and in case there is some oscillation like now, by lack of synchronization from the cable, for example, it will correct and measure. Do you see? And it corrects. And if there is a drift over half decibel, it will will stabilize and will repeat the measurement until that gap. Do you see? Now doesn't pass the test. Was 0.05 dB off. So it now take again the measurement to be sure. And now you see it's in the frequency, the right frequency, and is taking the right reference. It has 3 steps, and the last one is a validation. So we'll pass now. Always pass to the second one if the generator is good, but normally sometimes in the first one, sometimes in the second. So now this one pass is taking in one fast sweep all the noise floor in 1 megahertz span from the skirt of the carrier to 1 mega to measure fast, not precise but fast, the noise floor. And what it does, it takes the 28 points of that sweep and will add that values of noise floor to the calculations to from 10 kilohertz to 1 megahertz in the offsets. 10 kilohertz, 100 kilohertz, 1 megahertz will take that that noise and will use it to calculate to put the noise floor in the higher band of the spectrum analyzer. This is because the ADC has more precision reading in the top than at the bottom. So with that first sweep, what it does is put always the noise floor in the best level for the readings. And also, but even there is the noise floor is under so even doesn't take a reading from that. So as you see, also it's telling you in the screen, is a new thing. The stairs that you have is taking now the real phase noise, and is taking it in 28 points that later interpolate and make a trace. And also the reference automatically is adjusted to, like I said, to correct and have the readings in the proper place. I'm running out of battery, 1 second. So right now, when make this sweep of 28 measurements, it's in zero span mode, and you maybe cannot see it, but after it stabilize, what it does is take a measurement with the noise marker. The spectrum analyzer has a function here that it has a marker specifically to make the phase noise. So it's taking that, it fits, take the measurement in 1 Hz, so in zero span, so take a lot more precision than usually does in other way. Not only by the zero span mode, but also that marker make the have already the corrections and take the measurements to calculate the phase noise. So it's not only a marker, also it has other things. So also previously, before these 28 steps, it took 4 measurements with more precision, with average, and they are taken also to, like, for a dataset. If you don't need the 28 points and a trace, you only want the offsets. It takes 4 measurements in every offset with more precision, because it has average in 4 points. So the method that is following is based in I show you now, is following HP Agilent document of how to measure their the phase noise with their spectrum analyzers. It is using all the process. It's based in the official procedure, how to do it, in this manual of 124 pages. So it's based in this. So it's as good as I can. There is other software quite famous. I have time because it's in the 21. There is other software that does the same than mine does, but mine have the tracking generator and also the noise figure measurement. But this one from K5FX it's a nice software, but what I could see on it, that from 10 kilohertz this is not taking readings. So really, because the noise floor go out of the screen, but this software, even if it looks very nice and the important one probably is measuring properly, it results that all this really is not a measurement, it's a fake measurement. So it's not a real thing. I can show you. We will see when finished. But this is it's not being measured, so it's not real data, this one. So I know it's a good software, probably works better in other spectrum analyzers, because it's not prepared exactly for the mine. And it looks that maybe it doesn't remove the Vaseline, the own. Now past other step. Now it's making a sweep, that is the sweep and is making 3 sweeps with average, and it will be stitching, the software will be stitching the three measurements, the three offsets, to make the plot. That the plot is not precise, so these traces are not precise, but will be visually adjusted to the precision trace to physically fit to the other readings by interpolation. In the 25 points will be interpolated, and later this curve, once it's stitched by iteration, will be fitted to the real measurement, but it's only visually, and to get like visual information of what is going on. Maybe there is some spike, some spurious signal, and you can see it there, in case that some reading is higher than should be, because maybe you have a spur or something. So, and now it's already finished. This should give the results in the screen, but it's not doing now. Because this is what the Vaseline is in the diode when it do it. So once finished, I have now a Vaseline, the noise, removing and the software removes the cables, the attenuator, the losses, and the own noise of and characterize the noise of the spectrum analyzer with this equipment. When now measure the diode, will remove all this and just will be the difference. Alright, I hope that you understand me. I'm not sure. So now we can see the plot, and you have you have cursors. You can put cursors and see the deltas there. You can make zoom. You can you have the real measurement, the precise one. You have interpolation in yellow that join all the points, and later the sweep. What it does is visually by average fitted to the trace. So it's just visually. So you can remove every reading that you get. So what you can see here, these 4 points is the highest precision measurements. That is the one that would be, for example, in a datasheet. They are taken with zero span, noise marker, and also it has 3 averages and more resolution bandwidth. The other points, but likely, do you see? They are taken with ratio 110, so with less resolution, with less video filter, and also they have no average. But as you see, there is no many difference. But this is the most precise one. Later you have the interpolation and the sweep, and you can load other traces up to 4 of them and compare. For example, if one device Now I can use again the Vaseline, but with other attenuator or for example connect it to these 4-port splitters and see how much noise add to the system the splitter, for example. Or I can compare between different diodes. So now, once I measure, sorry, I need to use. I'm going to measure the another 6 GHz generator that is built with software in this Adam Pluto SDR, but it's quite nice because it has AM, FM, narrow FM broadcast, PSK, and this one is only CW, but this obviously this is cleaner than this, but we're gonna measure how good is this one. And you can compare also between different SDRs. They are different. So now we have this one, we can close and we can go to measure diode with the same with this profile that we just made, and we click and will be manual because it's other generator. So now it's asking you which is the power of the attenuator, so of the generator, because depending on what you write here, it will protect the spectrum analyzer and will ask you to add an external attenuator, or will protect adding maybe 30 or 40 dB attenuation with internal attenuator to protect the in case of accident, to protect the spectrum analyzer. So I'm going to prepare the software of the tracking generator. It's software based with a software called oh my god, SatSagen. Sorry, I need to tell it in English. In Spanish it's not the same. It's quite nice. It's a spectrum analyzer with tracking generator, also generator, but the generator have all these modulations. It's impressive. So I put here the same frequency, 2 GHz, same power, minus 17, minus 16, no, sorry, 15. I don't know the losses. I prepare. I put here the power, and what decide is that doesn't need any extra attenuation. It's safe. So as you see there, it's safe. So the attenuator carry on in 0 dB. Now it says active your generator. So I active the generator, and we can see that there is change there. Didn't clean the screen. So now we have the generator running, and we put enter and start. Should be clean the screen. I don't know why it's not clean, the screen. This is a bug. The fact is that, a sec. is this one. It's all on video, and you know, when finished I will put this available. So some dude measurement. I'm going to do the fast one. I didn't test yet. I'm testing, so you know. So 2000. Is finding the previous measurement, so we use that Vaseline. We don't need to make one. Power is -15. We know the. Did you listen? It went to 0 dB because to have the best measurement. The other software, this one, doesn't remove the attenuator, so you need to do it yourself and don't forget it, because if not, maybe that is the reason that it's not getting any data from the offsets. So one is activate, and now is doing the same steps that did before. I'm making only 4-point high precision measurement now, because it will take too long make the other again, and so it just will take only 4 measurements with average, and we will see which generator is cleaner. Maybe I have a bug or something. Should be cleaner, obviously, this one than this one, but you know, I need to check if I have some bug. This is the first test, but it's just, how it works will be the same, so I just show you how it does. You see, is have a drift in amplitude of 0.05, so it passed the power of carrier is -17 decibels. The frequency that read has drift also, but that is not that SDR is known by low quality reference, so, and it has not input for GPS DO, so it's normal that drift is more, but I have it corrected via software. So in this software, that is so nice, you can correct if you have some offset from the reference, internal reference, so you can I turned off the generator. I wanted to show you that, and I made an invalid. Oh my god, so wrong. I know, we know that won't be valid the measurement. Doesn't matter, it's just to. And as you see, is rising the reference. Now it's in -73, rising the noise floor to can be measured in the ideal point. Do you see? Because this other software, a part of the attenuator doesn't raise that, so it's reading under, so it's invalid measurement. So this software automatically put everything in level and everything is measured. And as you see, you have there the average, and now finish, and is giving results in DVC, and you have the offset there. in DVC. Did you see? It's quite nice. So once it's done, you have here what is selling here is in this offset is same or better than but we measure this one bad so we cannot take it in consideration. But now you can see the plot, or you should be able to see the plot. You see you have this one here, and we mess the we mess the measurement. I don't know. Well, it doesn't matter, and we can put the Vaseline and compare. We remove the traces and we just leave the points to compare. Obviously there is some problem that no, sorry, no, this is right. The we see here this spike here in 1 meg is because there is a spurious there and it's being measured. I didn't make the I know this, the result of this. So you have here more noise. Here is the same more or less, but you cannot see it because I damaged the measurement. So this is lower, is there, and this is missing as well. And this one there is a spurious that is in the, and it's right that reading. So and we then make the sweep to see the this got frozen or something. Yeah, this got frozen. Well, other book, but it works. So once it's finished, I will publish. So I hope you find interesting. So I will make other with the tracking generator and the noise figure measurements. So gives you a nice functionality. It's a nice spectrum analyzer, but lacks of the software of the new spectrum analyzer. So, but you have the GPIB port, so you can do it yourself. So it's software. Alright. Thank you for watching. I hope you find this interesting.